Well, I guess we can get started. Welcome, everyone. I hope you're all having a good day. Thank you for joining me today. The focus of this presentation is on using GeoHub 3D confinement for port and intermodal facilities. I'd like to thank you for all taking time out of your busy schedules to attend. A little about myself. I've been the chief engineer with Presto for the last 13 years. Prior to Presto, I was an engineering consultant for 20 years, focusing on all kinds of different types of civil and geotechnical projects. I'm an active member on REMA committees 1 and 5. I'm also a member of ASTM D18 Soil and Rock and ASTM D35 Geosynthetics, along with ISO Committee 221 Geosynthetics. So here are the things I hope you get out of today's presentation. Understand the benefits of using GeoHub soil stabilization for paved and unpaved surfaces, including the ability to use local, low-quality infill, recycled materials, and even coarse sand. How the system reduces vertical pressures and sub-base movement, and finally, how 3D confinement can reduce pavement depths while extending pavement life, along with reducing maintenance by providing a more stable base. If time permits, I would also like to briefly discuss concrete-filled GeoHub channels. We've been doing a lot of those when we're doing port and intermodal work, replace conventional concrete channels. So during the presentation, if you have any questions, please type them in the chat window and we can address them after the presentation. Presto worked with the Army Corps of Engineers to develop geocell technology in the late 1970s, and we continue to be the leader in innovation. We offer more than just a product. We will work with you from the initial concept phase through construction to support a successful project. We have a worldwide distribution network experiencing not only in geocells, but other geosynthetics as well. Our assistance does not stop when the product leaves our door. We operate in 4 product areas using our GeoHub geocells, which can be used for load support, slope and channel protection, and constructing green retaining walls. We have porous pavements, both vegetated and aggregate solutions, and lightweight reusable construction mats. Like I said, Taylor is going to focus on the load support application, hopefully a little discussion on the concrete channels. So let's begin with discussing how GeoHub 3D confinement can provide benefits for unpaved and paved surfaces. The GeoHub system consists of 2 main attributes. The first is the cell size. The cells come in 3 diameters, 8.5, 10.5, and 18 inches. The cell wall heights include 3, 4, 6, 8, and 12 inches. The actual cell size and height depend on site-specific project details and site conditions. We will provide a free evaluation. Typically includes a written summary, cross-sections, calculations, and specifications for free. No matter what size of a project, we provide the same amount of service. The ultrasonically welded seam where all the connecting points are located is very important to the function of a geocell. The stronger the seam, the better performance of a geocell, period. So a strong seam allows for better lifetime performance. GeoHub is produced using high quality, 100% virgin, high density polyethylene for consistent and strong welds to the seam. GeoHub geocells do not use fillers or exotic polymer alloy blends, which can ultimately reduce the weld strength, and they're offered in some competing products in the name of increasing cell stiffness and reducing cost. To avoid weld failures and the damaging effects of differential settlement, uniformity and performance across all elements of the geocell is much more important than stiffness alone. Here you can see a typical GeoHub panel. It comes tri-folded on a pallet. Each section has a nominal width of 8.5 feet, with lengths up to 52 feet, depending on which size you go up. The panels are very flexible. They open like an accordion, so they're very flexible, so they can accommodate not a site that is not completely level. For a geocell system to perform, it's critical that both the factory welded junctions and the field junctions that connect individual panels perform at a level that is commensurate with the cell walls. Therefore, incremental improvement in one characteristic is only valuable if an improvement has been made in the other components of the system. As I said, GeoHub is made from 100% virgin HTP. It's a proprietary formula that has been stood the test of time for more than 40 years. Contains no filler or exotic polymer alloys. For most typical sites, GeoHub retained its durability for greater than 50 years of lab testing, indicating 140 hours without degradation, even at full 100% exposure the sun shining always. GeoWeb and all of our accessories are 100% made in the USA. The system components are all the supporting pieces that help the GeoWeb protect the surface and the subbase and ensure relatively uniform performance of the interconnected system, thereby protecting against the damaging effects of differential settlement in response to a cyclical load. Presto is equipped with numerous design and construction components that can increase the strength and speed, whether that's for slope protection, channel. You can see a picture here of a very steep slope. We're using polyester tendons, which is here, almost like a set of drapes, and hanging off the slope. We use Attra tendon clips, which are tie around the tendons and bring the load up to the top of the crest. We have all kinds of different accessories, no matter if you're doing a load support application, a slope channel, or a wall. For load support applications, the Attra key is a major component for a completely integrated system. Attra keys connect GeoWeb panels into a single system. The keys' speed installation are made out of plastic and will last the lifetime of the project. Attra keys ensure that the panels will not separate and that the GeoWeb system will not fail under the anticipated cyclical loads. The specific engineering values of the Attra key will ensure the system holds up to loading over time without the corrosion seen in staples or the failure of underperforming zip ties. The purpose of the cellular confinement is pretty simple. It's basically just to stabilize the movement of unstable cells, whether that's horizontally or vertically. It is an engineered system integrating multiple geosynthetics with the best method of confinement and subgrade stress reduction. Here's a typical cross section for load support application. We start with a subbase, a bearing strength, typically expressed as a CBR, California bearing ratio, or an LBR. Then we decide if we need a non-woven or a woven geotextile based on the system application and subgrade type. 95% of the time we are going to have some type of geotextile underneath it, if it's unless it's the subbase is the same materials which go into the geo. When we are talking about woven geotextiles, I guess I'm referring to enhanced woven geotextiles and not slip tape wovens, which do not have very limited flow capabilities. So they're almost like a pool liner. So what happens is that they're getting kind of water pore pressure buildup underneath that geotextile. If you have a slip tape, it doesn't allow water flow. It can actually build up pore pressure and actually lead to a global failure. So we never recommend using slip tapes under geo for any type of application. A subbase may be required, and we'll determine that during our evaluation. We do our calculations. Then the geo is put down. Like I said, we can fill it with sand. Recycled materials, on-site materials, it has less than about 10% fines or crushed aggregate. Going to have a surface course. If it's unpaved road, we like to see a minimum 2-inch over the top, 2 inches, whatever the material side, and supporting the given load. GF3 confinement works this way. So when a vertical load is applied, the active rip pressure in the loaded cell pushes back against the passive rip pressure in the adjacent cell to form a stable system. So each cell helps support the ones around it. The GF cell walls transfer hoop stress, which is important to keeping the system intact. It creates what is known as the mattress effect. So the strength of the seams around each cell, the material stiffness of individual strips, and the connection method between panels are all important factors in determining how the geosystem can improve site conditions. So strong seams, semi-ductile, resin properties, integrated connection are critical to uniform performance. Here you can see the stresses on a typical on the subgrade on the unsupported on the left and the geo reinforcement on the right. You can notice how there's a complete elimination of high stresses at the surface with geo. Stresses are reduced and distributed over a wider area. Once again, we call that the mattress effect. So it reduces the stress reaching the subgrade and leads to a significant decrease in deflection and rutting. The second main attribute of the geo system is the infill. One of the important benefits is we can actually use, as mentioned, a low quality aggregate, recycled materials such as recycled or crushed concrete, and even coarse sand can be used. When we invented the geo back in the late 70s with the Army Corps of Engineers, the main use was for sand roads and beach and getting heavy vehicles around beach sand. And it was actually called sand grid back when we first invented it with the Army Corps of Engineers. We can also eliminate fines when desired, since cells provide the confinement. and aid compaction of cohesion of the soils. So without the fines, you can significantly improve drainage and let the water flow freely through the system, preventing pore pressure buildup and global failure. Also, you can use that open area, that void space, about 35% for 3/4 inch crushed aggregate. So you can imagine the amount of storage that you can store inside the geo of water. The ability to use sands and low quality aggregates really sets us apart from other geosynthetics. Those products require high quality crushed aggregates, high friction angles to achieve optimal performance. With our system, with the geo, low friction angle materials in the 20s are just fine. The geo panels achieve their full potential, even with these core materials, which can potentially be a significant cost savings if you can use on-site or recycled materials. Here you can see the impressive load benefits. This is an 80,000 pounds, so an AASHTO H20 loaded dump truck. This picture is actually taken up in the oil patch up in Canada. This is over a subgrade CBR of about 1.5, 2. So if you would walk across this, your foot would rut a little bit, but a heavy vehicle like this would probably create about a 6 or 8 inch rut. So you can see how the cells push back against each other to support the load, and only the adjacent cells need to be filled for the support. So a great benefit to using the geosystem is that you don't need to have every cell filled before that area is usable. So you can use that area staging or actually temporary haul roads. I'd like to speak a little bit on some recent research that we've done on cyclical loadings. And the research was conducted at University of Kansas under the direction of Professor E. Hahn, who has been conducting research on geocells for almost 20 years. Ben Lashinsky, Professor Ben from Oregon State, he did his PhD thesis on geocells. He conducted the finite element analysis. And Hai Hung from Penn State provided smart rock technology. We wanted to use the recent technology to confirm the stabilization benefits of the geocells. So that program was conducted over weak subgrades, like I said, performed at University of Kansas. You can see the different, we put under a 37.5 kip wheel. We varied the subgrade CBRs 0.5 to 5%. We did a bunch of different control sections and GM supported sections. Smart rock included a motion vibration sensor that could record rotation, translation, and orientation. The earth pressure cells were used to measure the vertical stresses and displacements at the interface between the surface and the subgrade. The cross section consisted of an enhanced woven geotextile, 6-inch geode filled with a crushed aggregate in an 8-inch surface layer. To evaluate the movement under cyclical loads, we put smart rocks inside of the geode panels here, and we also located a 4-inch right in between. This is an 8-inch cross section above the geode, so we went 4 inches, put in the smart rocks, another 4 inches in the earth pressure cells above that. So the goal is to confirm the stabilization controls movement not only in the cells, but also above the panels. Here you can see the smart rocks, how they actually measure. This is actually measuring the rotation. So under a cyclical load, when you're getting rotation, you're breaking down that material, which leads to loss of aggregate over time for an unpaved road, and basically attrition. You got to do a lot more range, you'll get a lot more rutting, small breaks in the smaller particles. And we also looked at movement. So basically this is movement side to side, and how that cyclical loading would move that material not only in the geode but above the geode also. This slide shows angular velocity, which is how fast the particle rotates. The two graphs on the left show the smart rocks are placed in the middle of that 8-inch surface layer. The two graphs on the right are the smart rocks are placed inside the geode panels. You can see the difference between the control section and the geode stabilized section for both sections. Very interesting that stabilization not only controls movement in the geode cells, which of course that would be assumed since it's totally confined, but you also see the graph on the left here, which shows here's the control section, so 4 inches above the geode panel, or this is 8 inches. Yeah, this is no geoweb, and here's 4 inches above the geode panel. Completely, so how much we decrease the amount of movement and the velocity of that particle moving. 4 inches above the top of the geode. And once again, here's the control section and the stabilized section of the geo. This slide shows angular acceleration, which is how fast the particle moves with subjection to cyclical loadings. Just like in the previous slide, you can see how the stabilization, once again, here's the control section. Here's the stabilized section. Once again, this is 4 inches above the top of the geo panels. Once again, inside the geo, control section and stabilized section. So a significant decrease in movement and rotation. The results clearly show that geoid stabilization significantly reduces particle acceleration and velocity, not only in the cells, but below the surface and between the top of the geo panels. So this will effectively minimize the movement of your infill by providing lateral confinement so that breakage, vertical compression, attrition, and spreading is minimized, and performance can be significantly improved. So by controlling particle movement and rotation, this will lead to decreased maintenance and running for unpaved surfaces and a more stable base for paved surfaces, which directly leads to cost savings. Here you can just see the finite element analysis. This is what Dr. Lashinsky did. The confinement was effective in redistributing, the vertical stresses on the subgrade, resulting in large areas of subgrade mobilization, shear strength, and reduction of plastic deformations. Geoid reinforcement decreased the pressure at the subgrade interface by over 50% for weak subgrades. Also increase the load-bearing areas of subgrade and result in decreased interface pressures. So this will also lead to decreased pressure in the subgrade, will result in lower subgrade settlements and running. So I want to go through some typical projects that we've done for unpaved and paved surfaces. Here's a typical problem. This is one of the first ones we did way back in the day. I'd like to show this one because it's a significant amount of running. This project was a real rush. It was a real intermodal facility, actually by our office in Wisconsin. Here you can see after a couple passes of 110 restacker, basically that what was happening is you're getting these significant rusts on the surface. So we worked with the rail company, came up with a solution. This actually was before we put in perforations and texture into our geo panels. You see, just dump a crushed aggregate on it, spread it out, and no running. So this was a heavyweight non-woven geotextile, 8-inch geo and a 3-inch wear source. So we went from rutting to a stable surface. This is an intermodal project we did for CSX down in South Carolina. As you can see in the picture, the 60-ton restackers were severely rutting on the existing aggregate yard. The rutting led to slowing down not only the unloading, but the loading of the containers, along with routine maintenance to keep the yard in operation. The subgrade here wasn't too bad. It was like 1.5%, 2%. There was a lot of fines, so it led to rutting. And you can see here, they had graders on this site almost continuously, because after a couple passes, that reach stacker, you can see almost halfway up the tire. So we worked closely with the engineering CSX to come up with the geoid system to support the load and eliminate the rutting. Based on the available geotechnical data and working with the geotech for the project, it was determined that the existing infill material or existing fills that was on the site could be reused to fill the geo panels. So this led to a significant reduction in cost and importing outside aggregate fill for the geo. So the solution consisted of an enhanced woven geotextile, 6-inch geo, and a 4-inch wear surface. You can see just the enhanced woven geotextile and the geo going down. You can see the geo panels being filled with the on-site soils. The contractor stripped off the existing surface material down to the top of the desired elevation. And you can see they just stockpiled that to the side and used it to fill geo panels. So like I said, eliminating the need to import that costly fill. The big thing this application is they completely eliminated the daily maintenance on that. So they got the plant or this yard back into service a lot quicker because they didn't have to import all that fill. You can see the final solution, geoid system supporting load. I said the geoid confines that fill, even if it's on site with high fines, essentially eliminating potential for running. Here's the project we did down in Mexico for Kansas City Southern Railroad. The original design called for reinforced concrete, but the bids came in well over what the budget was. So the sales range wasn't that bad, but the railroad came to us as a VE solution. We were close with the engineer once he came up with the solution. This was to support 80-ton reach stackers. So the design here is the same as last one. We put down an enhanced woven geotextile, 6 inches of geode, filled with a low quality fill in a 4-inch wear surface. You see it just being infilled with a low quality crushed aggregate. Here we limited the fines to about 15% to allow for some storage of stormwater infiltration into the site. And what this is a good photo. The truck just dumps the aggregate into large piles onto the panels, either with a front end loader or a bulldozer. The aggregate can just be pushed into the empty cells. It's a pretty fast and efficient process. It doesn't take any additional training or expertise on behalf of the contractors. Now here you can see the final wear surface. This one we actually, after placement, they wanted to a little bit keep the dust down, so they provided an asphalt tack coat, sort of as a surface stabilizer to control the dust. This was an interesting project we did. We solved 2 issues. This was a 2-acre site now in Pennsylvania where the owner wanted to increase the size of his manufacturing facility. The first issue was to provide a durable surface, of course, something that these big gantry cranes can operate over. The existing subgrade is about 1.5%. So through the design process, we came up with once again, this was a heavyweight non-woven geotextile, 6 inches of geo, and a 3-inch wear surface. The second issue was to provide on-site water storage to allow for the facility to reduce the volume. They wanted to go asphalt at first, but they didn't have any ability to expand the site because they needed to expand stormwater ponds. If they went with an asphalt surface, that's the main reason they came to us. We designed a system with that open grade 8 aggregate. So as a rule of thumb, a 3/4 inch crushed aggregate has a void space of approximately 30%. So you can imagine how much water we could store inside of that. They were allowed to use the water storing inside the geo as a credit, so they didn't have to expand their stormwater ponds. Just an up close picture of that open grade aggregate. Geo compaction, just want to mention that when you're compacting, whether it's a sand or high quality aggregate, a recycled material, open graded, there's no reason to really high strength vibrate this material. Usually just rolling over the top it provides adequate compaction. So just make sure that the construction supervisor or whoever, the engineer or the contractor on site, is aware that they don't have to really hammer with vibration. So just keep a light vibration if needed, but not a very high vibration. So once again, this facility, this was installed in 2001. You see the picture of the site in 2001. And 2011, there's been very limited maintenance over the last 20+ years. And this area is still in use today. GEOB is still in place. We do port intermodal work all over the world. This is a surface stabilization at the port of Invergordon in the UK. The site was 6 acres, consisted of two areas. One was 3.5 acres and used a 4-inch deep geo panels. And the second area was 2.5 acres and used 6-inch geo panels. The 2 areas were subjected to different loading conditions. So during the design phase, we worked with a consultant to determine the most appropriate panel depth to meet site conditions and provide a cost-effective solution. So the 4-inch area was used mainly for vehicle parking, and the 6-inch geo was used in a reach stacker and container storage areas. The area was constructed as an unbowed pavement with a crushed gravel surface. The geo presented the perfect solution to minimize the cross-section depth. Differential settlement on this site was a significant concern because there was a variable subgrade that varied from almost less than 1 up to about 5%. So we worked with the engineer to develop a cross-section that would bridge those low subgrade areas, and utilizing, once again, enhanced geotextile and geode, we could span those areas and prevent running and differential settlement. You can just see up close of the infill area. Like I said, there was a pretty low quality mixture of sand and aggregate. The biggest thing, it was locally available, so they didn't have to bring in a high quality crushed aggregate that was not available locally. So the original design evaluated geogrids, but the required high quality infill material was too expensive. That's why they went with the geo. Once again, compaction, just roll it or lightly vibrate it. And you can see the final surface after compaction, total 6 acres. And that was the final surface. Here's a project we did in South America, about 15 acres. Used a 6-inch geo. The main reason the owner selected geo was the ability to use the local sand fill. There wasn't any high quality aggregates or even really low quality for that matter, available at this port. So they used a sand infill, a locally available sand infill. There are many different installation tricks when installing GeoDub panels. This contractor wanted to make sure the first set of panels were installed very square, so we built some spreader frames and just added some fill, and just removed the spreader frames after the infill. I always tell when I'm on site, it's like hanging drywall. You want to make sure that the first 4 or 5 panels are installed good, I mean nice and square. Once they're infilled, then you can pretty much use the weight of that system to allow for installation. Doesn't matter how small the project is, the size. We always provide the same amount of technical support in our evaluations. Here's a project for a gantry craneway being used to unload trailers from railroad cars. You can see the significant amount of running due to the crane and the interesting method used to stop the running. They tried metal panels, timber masts, with no luck. We do a lot of work with the Class 1 railroads, not only in port but also rail. The Class 1 that operates this facility or works with this facility told the owners to give us a call. It was taking so long to unload their trains. Like I mentioned, a lot of project only used about 16 panels of GeoDub on each side of the track. We provided the full evaluation. Consisted of a heavyweight non-woven geotextile and 8-inch GeoDub along with a 4-inch wear surface, but completely eliminated the running. About 10 years this has been in operation. As I mentioned many times, we provide the free evaluations for all our projects, no matter the size. We'll include a written summary, cross sections, calculations, and specifications. Typical turnaround time is 1 to 2 days. We will totally explain how our calculations work, so you have a total understanding of how it works in the calculation methods. Now we'll discuss under pavements. Well, there's asphalt, reinforced concrete, lower compacted concrete, especially in areas with soft subgrades and drainage issues. We all created this slide and recognize the problem of an unstable base under hard pavements. Led to rutting, settlement, potholes, pavement degradation, and even total failure. The common contributing factors include differential settlement, localized settlement of the soft subgrade, as well as poor drainage that can lead to poor pressure buildup beneath the pavement and ultimately failure. So reducing the damaging effects of that differential settlement, protecting against the buildup of poor pressure are key factors extending pavement life and reducing long-term maintenance costs. The project was for Union Pacific Railroad in San Francisco. It is an auto storage area. The original design included geogrids with a high quality A grid. When construction started, the subgrade was so wet, it was soft. The geogrids just weren't a cost-effective solution. And to bring in too much of the high quality A grid, the engineer contacted us. We provided a value engineering solution using GeoDub. This one had soil strengths of around 1%. So we were close with the engineer and the railroad to provide a good solution. Consisted of once again the high strength woven geotextile, a 6-inch compacted base to really get that geotextile into tension, and then we put down a 6-inch GeoDub layer with a 2-inch wear surface, and then they provided asphalt over the top. Here you can see the expanded panels, open graded. They wanted to use an open graded infill, so we limited the fines to about 10%. This facility is right next to the bridge in San Francisco. So the high tides really can get up into that base layer. So we wanted to have some ability for the water to flow through the GeoDub panels. Just a closer view of the infill. Once again, aggregates just dumped from the dump truck and pushed into the cells, bulldozer, front end loader. Most of the time I see, of course, they have a GPS on them. So the GeoDub panels install quickly. The installation of the panels is usually well ahead of the infill placement. And here's the placement. They put 4 inches of asphalt over the top of the GeoDub panels. So a regular asphalt paver is used. It was compacted with a smooth barrel roller, no special equipment or procedures that are required when paving over the GeoDub panels. So paving crews can install at the regular speed without needing extra training or additional requirements of any kind. This is another auto storage yard for BNSF. This is a 25-acre site right by the airport in Seattle. Once again, a variable CBR, about 1 to 3%, average about 1.5 CBR. This one was interesting because once again, it was originally going to be a geogrid solution, but the city would not allow them to bring as much aggregate because it came right to downtown Seattle. So The contractor approached us for a V solution, and we were able to use the on-site material and mix with imported material, so it really significantly decreased the amount of aggregate that had to be brought to the site. Staging is very important for any large project. We have a significant amount of installation experience. We will be on site with the contractor for tips for quick and efficient installation methods. That'll be us or one of our reps all around the world. Here you can see one of the tricks we use is staging tables where adjacent panels are connected together prior to expanding into place and placed across the preferred subgrade. Each panel here has an area of 230 square feet, and this contract using a staging table to connect 3 panels. So basically a total area of almost 700 square feet. And using the staging table allows workers to stand up while connecting the panels with the Etcher keys. The panels are then transferred for installation. Typical installation rates are about 3,000 square feet per hour with a crew of 3. We'll also provide pre-construction installation training to the contractor, so we make sure that he has everything on site when we go to do the installation. This contractor, once again, wanted to have a pretty square panel, so we actually surveyed the entire site, and each one of these stakes is a corner of a geo panel. You can see a picture of the site with the installation, a 4-inch wear surface, using it as access. Once again, just dump it. Here they're using a bulldozer with a GPS system to install it, and here's the salvage stockpile material that they're going to use to mix and make the infill for the geo. Once again, just dump up to it and spread it out with that bulldozer, shown with the GPS on it, and finish service. This is a project for a port in Latin America. It serves a coal and a container storage area. This is an access road and a big storage area. Subgrade had a very low CBR, and the owner contacted us for a base stabilization system for supporting the asphalt and bridging those poor soil areas. So we were closely engineer. This one used 6-inch geo, once again with a heavyweight geotextile. We were also able to reduce the original pavement depth from 8 inches of asphalt down to 6 inches due to the reduction in the stress reaching the subgrade. But what led to a pretty big savings for the owner. Once again, just compaction, lightly vibrate. And here's the final surface before the asphalt layer is placed. You can see this installation, they actually compacted almost right to the top of the geo panels, which is completely acceptable. Just don't keep it like that for a long period of time, because if you get some heavy vehicles with shear and road, you could cause some of those panels by have to just do a little bit of maintenance. And here's the final access road showing the 6-inch asphalt surface. And the key, once again, the key to this project was providing a stable base and the ability to reduce the asphalt layer by 2 inches. Here's a really interesting project that I was on 3 years ago. It's for a Port of Panama. We were doing a storage area for unloading of the railroad cars. And during excavation, we were down there. They came into a site with petroleum contaminated soils. Actually, the Air Force gave this site to the port for free. And as we started doing the excavation, we ran into this material. The options were pretty limited. We could, remove it, or an off-site treatment, or we do an on-site treatment. Either of those methods were extremely expensive. Since we can use sand for infill materials, what we did is we just stockpiled the material. You can see over here, and every twice a day, the contractor would just go in there and excavate, try to volatilize some of those petroleum contaminated soils out, and we actually used that material for geo infill. So we didn't have to take any of those contaminated soils off site. We left them on site and used it for geo infill. And you can just see the geo panels going in after an installation. So for asphalt pavement service, once again, we provide the full design service. We use load equivalent factors. We use the AASHTO method for some calculations. We also use a structural design of heavy duty pavements for port and other industries. We have multiple designs we can use depending on how heavy and how many passes you have at your facility. This was a design build, Florida East Coast Railroad, right adjacent to the airport in Fort Lauderdale. In the overhead photo, you can see Geo panels, they had a big gantry crane here, so they're installing Geo to support the gantry cranes and areas around it. This was actually design built, so the original project was going to be based on geogrids and aggregate. So we went out with that for design build. It also included 8 months of surcharge over at the site to accelerate primary consolidation and protect against excessive, differential settlement in the future. One of the design build contractors came to us, and we were asked to be a part of the team to come up with cost savings to this system and prevent that long-term settlement, ease the concern. So we worked with the contractor and the engineer to come up with a geo cross section that saved 2 functions. The first was the ability to use on-site sand to replace the costly 3/4 inch crushed limestone that would need to be imported to the site by barge. So the specified, geo was too expensive. So the ability to use the sand infill saved us a significant amount of money and construction time. The second function was the ability of the geo system to control and short and long-term differential sediment to extend pavement life. Since geo significantly reduces vertical stress reaching the subgrade, it results in a more durable system with increased pavement life through controlling the settlement. We also cut that consolidation settlement down by working with the geotech. He redid his calculations with our stress reduction. We reduced that consolidation time in 9 months. So the design consisted of a high strength, enhanced woven geotextile, 6-inch deep geo panels, and an 8-inch sand cover. Here you can just see the geo panels being installed on top of the enhanced woven geotextile. So that combination of the geotextile and geo really will control the settlement, bridge areas of soft soils, reduce the stress in the subgrade. You can see the sand infill being placed in the cells, and this is just being compacted with the roller compactor with the GPS. Here they had installation of roller compact concrete pavement. The RCC pavement is an interesting wear surface. It's basically a low slump, high PSI concrete with with no reinforcement. Goes down and lifts up to 12 inches in depth. It is becoming more popular. We're seeing it in intermodal and port projects. Another advantage on this system, through the use of GEA, we showed through our calculations and working with the engineer, and we reduced the original design of 24 inches down to 18 inches. So we had, instead of 2 lifts of 12 inches, we had 2 lifts of 9 inches. So we saved 6 inches of RCC pavement, saving them significant money, not only in cost, but also in construction time. And you can see right after placement, the rollers are on it. Very durable surface. I was there before COVID. The site has settled a little bit, but it's settled uniformly, and no maintenance has been required. It's definitely within the limits they had set in the design. This is Port of Oakland. This is a project from the early 2000s. One of our earlier port projects. They wanted to use lime stabilization to stabilize the bay mud, but they were not allowed to use the lime stabilization due to environmental concerns and the associated project delays. The contractor, the project manager, was actually in Desert Storm. We installed millions and millions of square feet of GEOP for military access roads. He was very familiar with GEOP. He contacted us, and we did a VE solution to eliminate the lime stabilization, but also to significantly cut the cross section down. So about 250,000 square feet, that bay mud, just like in San Francisco, high tides, a lot of water, a lot of poor soils. So the cross section here consists of a heavyweight, non-woven geotextile, 8-inch geo panels in an 8-inch base. You can see it being geo panels being infilled. Another cost savings for this project is the international airport in Oakland was going under some pretty big upgrades at the time, so that ton of basically waste material, waste concrete from the installation of the new runways at the airport. So the contractor was able to use this material and crush it. We used recycled concrete for this project. So you can imagine how much time it saves, not only in the cost of materials, but also in the trucking, so it's right next to the port. The biggest need for this project at the time was the installation of the largest cranes at any port in the U.S. at that time. So the wharfs are still in operation today, very limited, not even bi-yearly maintenance. So the system is still in place. This is a project we did in Dakar during the pandemic for DP World. The port had a 250,000 square area needed upgrades to enable operation of the rubber tired gantry cranes. So the terminal needed base layer and surface stabilization. Biggest considerations from them was cost and timing of installation. This was a design build, and GeoBit offered, value engineering considerations and benefits such as fast installation time, reduced cross section, and with no need to surcharge. And it also eliminated of the cement bound layer. This actually used pavers, so they always typically require a cement bound layer underneath the pavers, and we completely eliminated that. You can see the recommended cross section from the engineer. We do a lot of work with DP World, and they look at GeoBit soft areas consists from a differential settlement is concerned. And typically they're using 100, 120 millimeter pavers on top of the GeoWeb. This was design build. Once again, it was during COVID, so with the COVID travel restrictions, on-site support was limited to Teams calls. Not even our distributors could not access this site, so the contractor was able. We worked with him with our online webcasts, videos, and installation guides. We connected with them along with our local distributor, via Teams. We went through our detailed website, provided all the necessary information so they had a successful project. Our website has a link to our YouTube channel, has hundreds of videos showing proper installation techniques. So typically we will have an on-site person to help the contractor get started, and also the pre-construction meeting beforehand. Once again, interlocking concrete pavement blocks were used. The first 100,000 square feet area of the container yard is successfully installed just before the rainy season. It has been in regular use with no settlement or maintenance needed over the last 3 years. Even with the exceptionally heavy rain and flooding events, to date, no settlement has been experienced. This is a project that we are working on actually right now with DP World in Manila. This is a 3-acre site. CBR about 5, so it wasn't really that bad. But when they looked at doing the design for the cross section, using the design of heavy duty ports method, the cross section was pretty significant due to the heavy loads. So we worked with them to reduce the cross section using GeoWeb. Here you can see an overview of the site. You can see that they already installed, the 1.5 acres of GeoWeb here, and they're filling it, and they're excavating here out for the next phase. We did include a geotextile separation layer on the GeoWeb. This one actually had a 30-inch base, a 6-inch GeoWeb, and a 1-inch sand leveling layer, and then the paving blocks. We reduced the cross section by about 25%. The GeoWeb was selected for base lay load since it reduced, like I said, basically the over excavation and the backfill that was required. So we limited the requirement for using the high quality aggregate and also that cement bound pavement. So it led to a significant cost savings. The local source crushed rock was used for the base and GeoWeb infill. Here you can see just a close up. This contractor once again wanted to have a very precise installation. So they used number 5 rebars in every cell or every other cell to make sure the installation was perfect. And you can see how nice that installation looks. You can see once again the panels being filled with that less costly. It's a sandy crushed aggregate material. Start out with the little bobcat, and they come by with a dozer or with a bulldozer with the GPS system. So as I mentioned earlier, and for any type of hard surface pavements, we're going to have a full design, including cross section, calcs, we can provide specifications for concrete, well compacted concrete, pavers. What method we use will depend on what type of pavement. Like I said, we can use ASTRO method. We can use the guide for well compacted concrete if that's what you're going, or we can use the British ports method if it's for pavers, and the structural design guide for ports. So there's a lot of different methods that we use, and we'll work with you on that method. So in summary, the GeoWeb system can be added to your project to provide a more stable and longer lasting service course for unpaved, which will reduce maintenance repairs. For paved surfaces, including asphalt, RCC, and reinforced concrete, GeoWeb decreases pressure on the subgrade to reduce differential settlement and long-term settlement to extend pavement life and maintenance. The ability to use those low-quality aggregates, coarse sand, recycled materials, and really provide a significant savings to your project, not only in the cost of the material, but also in the cost of transfer. The ability to reduce the stress on the subgrade, potentially reduce the final pavement thickness, And we offer that free, complete solution in our design package. I'll just take a quick time on concrete filled geob. We did concrete filled geob. We do a lot of geob filled, or we see a lot of concrete filled channels along ports in the mill yard to control drainage. We've done a lot of study at the hydraulics lab at Colorado State. Out in Fort Collins, under the direction of Dr. Chris Thornton, who is probably one of the most worldwide experts in hydraulic modeling. This is at the Horseshoe Reservoir. It has 250 feet of static heads, so they get a lot of water through their indoor and outdoor flumes. We did the channel study on aggregate, topsoil, and concrete filled geob. So we have tools and methods that we can provide aggregate solutions for riprap to significantly reduce the size of riprap, topsoil channels that are not routine flows, and also hard armor concrete. And that's what the majority of the ones that we have constructed along with ports, just because of how much water is on a site. So for concrete, we ran 3 different tests. Concrete was 3-inch geob, 2-to-1 sides or slope. Velocities were the 36, shears up over 21 pounds per square foot. We're the only geosynthetic, including ACBs, turf reinforced mats, erosion coat blankets, any other kind of solution to ever max out the flume at Colorado State. So we're pretty confident that we can provide a concrete channel that's going to save you money in construction and costs, but also a very durable surface. So this is the kind of flow rates, 3 tests of 1 hour. So a significant amount of water. There's many benefits to using concrete in filled channels. The fact that it's a total integrated system for all application, geob panels act as the formwork, so you don't have to have any formwork, or providing internal reinforcement. There's no rebar needed. The geob cells and the connection between the perforated sections provide the reinforcement. So think about the material and labor cost savings, since there's no rebar that is required. The speed of installation is decreased significantly due to elimination of rebar. So you just fill the geob panels with concrete and screen it to the top, and that's your channel. The panels are very flexible, so we can install on curves, dips, different slopes. All you do is adjust the slope in the field to handle the different slope angles, even your verticals. You can see at this culvert. What they did here is they just formed it up, and here they're screening it and pouring it. When they get up to here, they almost had their hand placing that. It's almost at a 75-degree angle. Just a slide showing a typical panel going in. This one used tendons, polyester tendons, and a pipe rebar or a pipe dead man at top. So you just run these polyester tendons through, tie it off to the pipe bed dead man. You bury that. It's just like hanging a set of drapes, where you secure it from the top and they hang down. Here you can see they're just pumping in the geob or concrete into geob, adjust the slope in the field, screen it off to the top of the cells, and there's your channel. And just a finished installation. Here's the project. This was a big project we did for Union Pacific down in Laredo, Texas. The original used reinforced concrete on the side slopes, 2-to-1 side slopes, 6-inch depth here in the channel. And then they used 2.5-inch grout bags on these side slopes. So when it went to costs, went to bid, it was a significant price over budget. So they came to us for VE opportunity. So we came up with the geob system where we use 3-inch geob concrete filled on slopes and 4-inch geob in the channels here. This is what's over 750,000 square feet of geob. We used a little thicker concrete in here because they're going to use trucks here on a routine basis to go and clean out the material that's in there just for sediment removal. Here you can see the concrete once again just being placed. It's being placed into the panels. A couple guys taking a break. And here you can see the extent of the going all around this intermodal yard. 50,000. They saved a significant amount of money. Here's the 4-inch deep in the channels. They saved a significant amount of money in cost. You can imagine eliminating all the time of forming that for reinforced concrete, 6 inches reinforced concrete, placement of the rebar. They replaced it with 4 inches of geob, so it significantly reduced the depth, but all that, the labor savings and the time was the biggest thing for the port. They got into service months earlier because it sped up time so much. A question we get all the time is costs. We have a base comparison, low CBR, 0.5%. That's where GEA really shines is, the 3% and less, those are low subgrade strengths. All geosynthetics have their place, but we really shine in the low subgrade CBRs because we have such a significant amount of stress reduction, and we can cut down that cross section. And also we could use, the salvaged on-site materials typically. You're going to save not only in material costs, but also in the aggregate savings. So when looking at a GEA, you got to look at more than just cost of the material. You look at the cost of overall installation, the aggregate savings that maybe you're using on-site materials or less quality or less costly aggregate. And we can help you provide those opportunities. And if we know we're not the perfect solution for all applications, we'll work with you and our local distributors all around the world to provide the best, the most cost-effective and best solution to fix your problems. We have a very detailed website, prestogeo.com. Many tools for you. We have quick links for everything from products through applications, design, installation. Here's learning, where all of our online webcasts are stored. Here's our YouTube channel. Has hundreds and hundreds and hundreds of videos. If you are interested in doing a project evaluation, you just click on the get a free project evaluation. That opens up this tab. Fill it out. Send any information. And if you have any geotech report or cross sections or proposed designs, and from there we'll take it in a couple of days, usually 1 to 2 days. We'll get back to you with a full evaluation for your review, and we'll hook you up with our local distributors so they can provide costs also. If you want to discuss a project, just reach out. We're readily available, have any kind of discussions, and if we're not a good solution, we'll point you down the right path. To make it faster and easier for you to obtain your PDH certs, so with our webinar dashboard, you can easily view our library once again of the webinars and download PDH certs. For on-demand webinars you complete, we'll also keep a record of all the webinars completed along with the PDH credits earned. So please note that the certificates for live webinars are managed separately from the on-demand webinars. You won't find your certificate from today in there, but you will receive an email from GoToWebinar in the next day or so containing a download link for your certificate. So in 2 to 3 days, you will receive a separate email from Presto with more information about accessing the on-demand webinar dashboard and other helpful resources. If you do not receive any of these emails, please check your spam folder or reach out to us. So with that, I want to thank you for taking time out of your busy schedules to listen to me talk for a while. My contact information is listed here. If any questions come up later, please reach out via phone or email. If you don't have enough information for a full evaluation, just give me a call or one of our team. We can discuss the potential for using GEA. Or once again, if we're not the right solution, we'll point you in the right path. So to understand that we're not the correct solution for everyone. So once again, thanks for your time, and see, we got questions. Oh boy, questions really good. What is the limit for fines? Typically, I shoot for less than 15%. We'll help you with that. We'll work with you. If you thought you just send us any gradations you have, then we can work with you. Low quality, what are the minimum requirements, gradation size? Oh, so this one is on gradation size. A rule of thumb for any GeoCell or GeoWeb, we're shooting for an aggregate size that's maximum of 1/3 of the cell height. So it can vary. It can be a sandy crust aggregate. If you have a 6-inch Geo, we're going to make sure that we use a 2-inch crust aggregate or less. This fine is the gradation requirements. Just make sure that you have the fines. You don't have a lot of fines, so less than about 15%. Oh. Yeah, distribution. Sorry, I'm having a hard time looking at it. What is CBR? CBR is the California bearing ratio. It's used as a geotechnical term for the strength of a subgrade, easily correlated to shear stress and SPT, or the N value. If anyone's interested, you can reach out. We have a CBR chart that the geosynthetic industry is pretty much, I guess, all agreed on, where we have CBR relations to SPT, blow counts, and shear strengths, and I can get you a copy of that. Any examples experience using below active passenger tracks, performance, longevity? Yes. The railroads use it all the time, all over the world. All the class ones use it, especially under their high stress areas such as crossings, diamonds, turnouts, frogs, things like that. We use it under high-speed rail. Network rail in the UK is standardized on GeoWeb under the track for any kind of, I guess, any kind of low subgrades for they're worried about settlement or issues with the rail actually not meeting their design standards. So I actually worked with Network Rail. We came up with a design method for using this under track. But we have millions and millions of square feet under track in passenger trains. It's usually replaced right underneath the ballast layer. So if they have to do any maintenance in the future, such as tamping. So if you got a 12-inch ballast, the geo is placed under that. We have calculations once again for all of that. So if you have a project, we can work with you on that too. At some point in time needs to. So what about when the geosystem is removed? What reason easy to take up? It's actually real easy to remove. You just expose a couple cells and you hook up. A lot of people I see contractors hook up chain up to it and on the back of a truck or bulldozer and just pull it right out of the system. Because once it loses its infill material, it loses all its strength. So it's very easy to remove. Also, another point, if you're doing construction and you have to access, say, a pipeline above or below the geo, most contractors, it's really easy, very easy to cut. The best way I've seen it by contractors is a PVC pipe saw. And they just cut right through it, remove that section, and then once you're done with your maintenance, you just butt the new geo panels to the maintenance area and fill it in and backfill it for compaction. Can you use system used for tall embankments on compressible subgrades? Yes, yes, it can be. Whether it's up, it all depends what type of. A lot of times we build geo walls, reinforce slopes with it, but we can also use it on those type of backfills. Someone got the time wrong. For you, if you missed the time, it'll be on our website under the learned section pretty soon. You can just go access that. Thank you. We'll hand out to this webinar recordings. Yes, that learning section of our website will have this webinar in a day or so. Keep asking about cost. The cost range. We have 3 geo cell depth up to 12 inches. So it really depends on what cell depth. We have the different cell size. We have the 8.5 inch, we have 10.5 and 18-inch, circle, basically circles of the geo. So it really depends on site specific. We don't have any, I guess, standard charts or tables for sizing it because we'd rather do the calcs. Every single project no matter the size. So if you want to just reach out to us, we can help you with that. Concrete field geo, how does the concrete form without reinforcement? Temperature, cracks, yeah, think about the geo with cracking is almost each cell is a construction joint. So all concrete's going to crack. It doesn't matter if it's reinforced, RCC, and geo, concrete over time is going to crack. But the good thing is that each cell provides, like a construction joint, so you're not going to get uniform cracking throughout the whole system. When we use it on any kind of surface, we've actually used it for roads down in South America where they fill the concrete right into the geo and drive over the top of it. Has a concrete spill been successful in cold weather climates where frost? Yes, we will actually design it. In that case, we have channels installed in way up in the oil patch in Canada. Significant. I've been up there when it's 30, 40 below Fahrenheit, and we're installing Geo for load support applications. We also have a lot of concrete channels too up in Canada. Copy of the presentation. Yeah, again, it's on our website. PDH process. You'll get an email and follow up in a day, couple days. If you don't get either one of those emails from GoToWebinar or from Presto, please reach out. When used trackbed, could the GeoCell reduce vibration? Yes, it does. We actually had a study with Amtrak that we were going to actually look at this. It was right before COVID and it got defunded. But since we can reduce the stress on the subgate, we can reduce vibration. We're still waiting to have that to get funded to do that vibration analysis. But yes, it can reduce the vibration. Cover on top of concrete. What is the minimum cover of concrete on top of the Geo? We recommend 0 inches, just right to the top of the cell, because anything above is not reinforced and it can crack. Are all the products perforated? Yes. It's very rare we don't have a perforated GeoCell or a request for a perforated GeoCell. All right, it looks like that's all the ran a little bit late. I apologize for that. If you have any questions, like I said, please reach out to me. If I missed your question, please reach out via phone or via email, and I'll make sure you get your question answered. So once again, I appreciate it, and everybody have a great day. Thank you for attending.